Let's go to Lick 3,394. Check if grid can be cut into sections. So it gives us n, which is n multiplied by n grid. And there are rectangles. Those rectangles are represent using an array which has a start x, start y, and x and y. So it asked whether it is possible to either to make the have the two cuts, either two horizontal or two vertical cuts, so that each of the result section formed by the cuts contain at least one rectangle, and each rectangle belongs to exactly one section. So that means we are trying to see whether there is cut like this to put those kind of rectangles into it, or whether it is possible that we have two cuts like this way, right? Trying to see whether we can have every section has rectangles. Right? So if we thinking about instead of consider rectangles, we can consider only x-axis and y-axis. And for x-axis, we can separate those kind of rectangles into like intervals, right? So you see, we have interval here, which is from 0 to 2, right? And for this interval, it's 0 to 1, right? And this interval is 2 and 2 to 3. And this interval is 3 and 4, right? So we'll see. We have an interval here, interval here, interval here. We have three independent intervals. So it returns true. So for y-axis, we have a similar conditions, right? That is, we will see we have a interval from 0 to 2, right? To 2. And also this is 2 to 4, right? 2 to 4, 2 to 4. And the green one is 2 to 3, right? And the blue one is the 4 to 5. So it is possible we separate that we just consider this kind of interval, right? Intervals. It's possible that we can separate this kind of intervals into three sections. So after dividing those kind of rectangles into x-axis and y-axis, we just trying to see if those kind of intervals can be set into more than three, greater or equal to three sections of intervals, right? So to see if those kind of interval can be separated as more equal or more than three sections, right? We just use a swipe line, right? For this one, we have +1, +1, -1, -1, right? So if we have a current count, this is add 1, this is 2, -1, -2 equal to 0. When it goes to 0, right, we have count should plus equal to 1, right? So when we swap from the left to right, this current count is greater to equal to 3. That means we can separate this one into three sections. So let's write code for this. First, for those kind of rectangles, we need to put that into um, those kind of points, right? So for horizontal, we have horizontal list equals new array list. And also we have list of int. We have a vertical list equals new array list. So for every rectangle, we're going to we're going to put it into horizontal list and vertical list, right? Horizontal list will add a new into this kind of point. For the left uh left so that is actually index zero, right? Index zero, that is R0. This is a horizontal entering event. So we'll have horizontal list add new int. So this is the R2 is living events, right? So vertical list we should add a new int in the R1. This is entering events, and also vertical list we should add new int R3. This is a living event, right? So just a return is valid, right? Is separate as valid um, horizontal list or is valid vertical list. So we use a swipe line to for this kind of list array, right? To list points transfer with where it can be separated as three more greater equal to three intervals. Is valid. So we work on the list of integer array. So what we do is that we need to sort collections, sort list comparator, comparing int. We are going to have int a goes to firstly compared by the the index, right? Then after this, we are going to have then comparing int. We put living events first, right? Because that so that for the same point, if we leave and then enter, there is no overlap. And so what we do is that int a goes to a1, right? So what we do is that we're going to have count because we count the different segments and current equals to 0. So we use a count to accumulate those kind of diffs. So what we do is that for every point in list, so we're going to have current should plus equal to P1, right? So what we do is that if current equals to 0, that means um, we find a segment, right? So then we have a count should increase by 1, right? So what we do is that if this count is greater equal to 3, then we return true. Otherwise, we in the end return false. So if there are error rectangles, right? So those kind of that will be every list have two error points, and we have sort, right? So that is an error log error time complexity in a linear, that is L space complexity. Python code will be very similar. So we need a horizontal list and a vertical list. So what we do is that for R in rectangles, what we do is that the horizontal list append R 0, 1. In the horizontal, we should also append R2 minus 1, right? And vertical list should append R1. And vertical list should append R3 minus 1, right? So what we do is that we just need to return is valid horizontal list or is valid vertical list, right? So we define is valid, and we should have a list. A list. Then what this one is, so we need to have this list to be stored. P equals lambda x. So it should firstly sort by x0, then sort by x1, right? Then what we do is that we need a count and a current equals 0, 0 for p in list. So what we do is that current should plus equal to p1. If current equals to 0, right, we find a segment, then we'll have a count. This segment count should plus equal to 1. Right? So if count greater equal to 3, we just return true. Otherwise, when we finish the for loop, we just return false. Is the sort p equals lambda. Let's put this one into a list.